Warning, the video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. If you're watching my video series in order, you know that you've gone through a couple lemmas and uses of those lemmas. And now we finally get into the meat of this section, which is titled Derivatives of Trigonometric Functions. We're actually going to present the theorem and prove at least parts of the theorem. Most of it is actually left for the student to prove in a homework or something like that, but it's good to see at least the very first proof. So let's go ahead and get to that. And here's the long-awaited theorem involving the derivatives of trigonometric functions. I want to draw your attention to some patterns here. First, I'll just state them out loud. Derivative of the sine is the cosine. If you're one of my students, you probably already know this because I showcased this in terms of graphs early on in the course. So the big three, the derivative of the sine is the cosine. The derivative of the cosine is not the sine, it's the negative sign. So be very careful with that. And the derivative of the tangent is the secant squared. Those are the big three. I'm not saying that the other ones don't occur. In fact, they occur quite often, but these are the kind of the big three trig functions, right? Sine, cosine, and tangent. Notice the derivative of the tangent is secant squared. That's critically important. All right, the other ones, the reciprocal functions, the derivative of the cosecant is the negative cosecant cotangent. The derivative of the secant is the secant tangent. And finally, the derivative of the cotangent is negative cosecant squared. Something that I want to draw your attention to is when I was saying the word co. I was emphasizing the word co. The derivative of the cosine is a negative value. Okay, it shouldn't be negative value. It's the opposite of a trig function. So derivative of cosine is the opposite of the sine. Derivative of the cosecant is the opposite of the cosecant cotangent. Derivative of the cotangent is the negative or the opposite of cosecant squared. Actually, in that case, it would be negative. So that's one of the patterns I want you to see is when you take the derivative of a co-function, your derivative will have a negative sign in front of it. Now, to be clear, just in case there's somebody, a professor watching this, all trig functions are co-functions. I totally get it. However, what I really mean when I say the derivative of a co-function is that the trigonometric function you're talking about starts with CO. Cosine, cosecant, cotangent. Okay? So that's a good pattern. Also, look at these guys right here. I'm going to use a different highlighter for this. The derivative of these two reciprocal functions, the cosecant and the secant, involve themselves. That's important. And then they involve a similar style of trigonometric function. When I say similar style, the derivative of the cosecant has itself, the cosecant, and a cotangent. The derivative of the secant has itself, the secant, and a non-co function, which is the tangent. So a lot of different ways you can kind of pull this together. These are all memorizable. You should not require at all a table or a sheet of notes because when you get into Calc 2, these just appear all over the place and you have to be willing to just remember them right then and there. These are memorizable. There's no questions about that. Now I'm going to go ahead and prove two of these. And the hardest to prove of the group are these two, this guy right here and this guy right here, because those are the basis for all the other proofs. Once you know that you've proven one of these, you can use it in any other proof that you want. So once I have proven that the derivative of the sine is the cosine, then if I need that somewhere else, I can use it. And I'll show you what that means in a few moments. But let's go ahead and prove that the derivative of the sine, I'm going to prove number one there, derivative of the sine is the cosine. And I'll probably assign something for my students to have them prove that the derivative of the cosine is a sine or something like that. Negative sign, by the way. So the derivative with respect to x of the sine of x. Well, we know by definition of a derivative, that's the limit as h approaches 0 of sine of x plus h minus sine of x all over h. And we also know from trigonometry that the sine of x plus h can be written as the sine of x cosine of h plus the sine of h cosine of x. Sum of angles formula for the sine function. There's something similar, but not exactly the same, for the cosine. This is all over h. Now what I'm going to do is break that into two different fractions. Let's see, I want to break it into the middle fraction, so let me grab the middle piece there. The limit as h goes to 0 of sine of h cos of x over h. And I'll give you a reason why I want to do that, because h is going to 0 and sine of h over h. I know that fraction will turn into the number 1 from our earlier lemma, and that's why we proved those lemmas. The rest of it I'll leave as a single fraction, so plus the limit as h approaches 0 of sine of x cosine of h minus sine of x, and this is all still over h. So far so good, right? Notice in both those limits there are factors of cosine of x in this first one and sine of x in the second one that can be moved out. So that is, I could rewrite this first limit as the cosine of x times the limit as h tends to 0 of sine of h over h. And the second fraction there, or the second limit, I could factor out a sine of x, because again, I can factor that out because this limit is not moving x, it's moving h. And because it's not moving x and it's only moving h, and because sine of x doesn't have an h, I can pull that out. Same argument as to why I pulled out the cosine of x in the first factor, or first term. And we know from the lemmas, this will be cosine of x times 1 plus sine of x times 0. Right? The limit as h approaches 0 of cosine of h minus 1 over h is 0. And so this turns into the beautiful cosine of x. And we have now proven what we wanted to prove, which is that the derivative of the sine is equal to cosine of x. There you go. QED. Now just reminding you, once you have proven that the derivative of sine is equal to the cosine, you never have to prove that again. But you might have to use that derivative in other proofs. So, for an example, let's go ahead and prove that the derivative with respect to x of the cosecant is negative cosecant cotangent. Well, in this case, I could easily do this a lot faster not using a limit. Now you have to use the limit proof for the sine and for the cosine, but for all the other ones, you can just use what I'm about to do. The cosecant, I know my trig is 1 over the sine. And now you can see you're dealing with a quotient. And I know the quotient rule because we've done that before, right? It's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. Well, the derivative of 1 is 0, so that first term is gone, upstairs that is. And we just proven that the derivative of sine is the cosine. And this is all over sine squared. And now I just look at what I need to prove. I need this to be a cosecant cotangent with a negative out front. Well, that is a negative out front times a 1 over sine of x times a cosine of x over sine of x. And that is totally a negative cosecant of x times cotangent of x. QED. So 2 proofs for the price of 1. So the rest of these are fair game. Your instructor will probably have you prove 1 or 2 of them, who knows, in addition to the cosine proof, or vice versa. They might have you prove the sine, but I would have my students prove the cosine derivative. That's it for this video. I just wanted to introduce this theorem and do a couple of proofs. In the next video, we'll start computing derivatives involving trigonometric functions.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much. That isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.